All right, good morning, everybody. Hopefully, you had a good week off and time with your family for Thanksgiving. 15 days left, including today, for the semester, so things are winding up quickly. So, um, next section is actually a good section to go over because it kind of reviews what we did before Thanksgiving. And before you see the word proving, we're not doing proofs. We're done with proofs for the whole year, the rest of the year. Proving a quadrilateral is a parallelogram. So you'll see that drawn shape, like we draw a triangle for triangle, parallelogram for parallelogram. So we talked about before the break that there's four things that we know about a parallelogram. So if we have a parallelogram, then opposite sides were congruent. Opposite angles were congruent. Diagonals bisect each other, and that consecutive angles were supplementary. Okay, so in this section, we have, and all those were theorems. I didn't write them out as theorems, but they were theorems. Let me go find one and read it just for the sake of that. So if a quadrilateral is a parallelogram, then opposite sides are congruent. Okay, so in this one, we're just dealing with the converse. If both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. If both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. Okay, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So we have a converse of these first three. That just means if you know it's a parallelogram, then both sets of opposite sides are congruent. If you know both sets of opposite sides are congruent, then you have a parallelogram. You can go either direction for the first three things that I listed. The fourth one is different. Okay, so what that one says, so it's kind of a separate category. It is a theorem. 7.9, and it says if opposite sides are parallel and congruent, then the quadrilateral is a parallelogram. So what it's saying is it's just one pair. So if this side was parallel and congruent, okay, then I have a parallelogram. If this side, I'll do two arrows and two, was parallel and congruent, then I have a parallelogram. Okay, it just has to be one pair of sides, but that side has to be parallel and that side has to be congruent. If I had parallel on the top and the bottom, but congruent on the left and the right, not a parallelogram. It could be, but it doesn't have to be. Okay, so that's the only difference between the two. So this, theorem 7.9, you can't work backwards from it. It is what it is. And the number 4 on proving a quadrilateral is a parallelogram, number 4 appear consecutive angles are supplementary. It has to be a parallelogram first. Then consecutive angles are supplementary. Okay, this one doesn't have to be a parallelogram, but it's the 7.9, but it's a way of showing that it is parallel and congruent. Okay, so there will be your first 6 problems. State which theorem you can use to show that the quadrilateral is a parallelogram. And so you're just going to list either 1, 2, 3. You don't have to, not the numbers, but just say opposite sides are congruent, opposite angles are congruent, diagonals bisect each other. You can just say that. Or you're going to say opposite side, parallel, and congruent. Okay, so you don't need to list, it's theorem 7.4, anything like that. Just write out the words. Okay, so then the rest of them are going to be different versions of the directions. We'll say something like find the value of x that makes the quadrilateral a parallelogram. Okay, so you're really just solving it. It's kind of similar to when we did parallel lines. We had, well, if the lines are parallel, alternate interior angles are congruent. If I could show that alternate interior angles were congruent, then the lines were parallel. So I could go back and forth. Okay, so, if you had a problem like this, okay, so for what values of x and y makes this parallelogram? Well, so I'm still going to just do 2x minus 1 equals x plus 9, because if the opposite sides are congruent, I'm good. I wouldn't want to use the y, and I guess I should make that look a little bit more like a y, but the y and the x plus 7, because they're different letters. So start with this one. Subtract x, add 1, and x equals 10. So that's one of them. For what value of y? Well, I need to plug in 10 for x on the other one. Excuse me. Okay. So just assume that they are congruent and solve the problem. If it involves diagonals, then the diagonals are going to be congruent or equal. If it involves the angles, they're going to be congruent. Okay, so a lot of the similar type stuff. Okay. All right, then the last 4, it's going to say graph the quadrilateral with the given vertices, so it's going to give you some points. Then show that the quadrilateral is a parallelogram. Okay, so look at that. All right, so if I have the points 2, 5, 5, 2, 0, 0, and negative 3, 3. So negative 3, 3, 0, 0, 5, 2, and 2, 5. So it may not look like it because of the graph not being on graph paper or whatever, okay? So really what you're going to do is just you're going to do your triangles to show distance. And you need to show that the opposite ones are the same. So here's like, so if you had a triangle here, so that would be down 3 and to the right 3. So 3 squared plus 3 squared, 9 plus 9 is 18 equals c squared. Well, if I go over here, three and 3, same problem. Okay, and then do the same thing with the other side. So that's up 2 and to the right 5, and then that one is 5 and 2 also. Equals c squared. Okay, so for those problems, I need to see them graphed. Okay, and I want to see the triangles. And if you just draw the triangles and show that I got 3 and 3 and 3 and 3 and 5 and 2 and 5 and 2, I'm good. Okay, you don't even necessarily need to write down the 3 squared plus 3 squared or the 2 squared plus 5 squared. Okay, so if you do those, put them on a graph and show me the triangles, you will get credit. Otherwise, I'm not giving you credit. I'm just going to mark off the assignment. Okay? It's only 4 of them. All right, so go back and review a little bit, like just to, we kind of did today with if it's something's a parallelogram, opposite sides congruent, opposite angles congruent, diagonals bisect, and consecutive angles are supplementary. I go back and even look at 7.1, polygon sum, the n minus 1 times 180 for the sum of angles on the interior, and look at, exterior angles, the sum's 360, no matter what the shape is, stuff like that. Okay? All right, have a good day. Hopefully you're doing good, and we'll see you tomorrow.